It is crucial to emphasize to the homeowner the importance of obtaining permits for electrical and plumbing work. Permits ensure that installations meet electrical code and safety standards, protecting occupants and property. Explain that failing to obtain permits can have serious consequences, such as firstly, safety hazards. Improperly installed electrical or plumbing systems can pose fire, shock, or water damage risks. Secondly, legal liability. Homeowners may be held liable for any accidents or damages caused by unlicensed work. And thirdly, permit fees. Permits are typically required to legalize the work and may involve fees. Now focusing on electrical violations. The depth of the 12/2 underground feeder cable must meet code requirements, typically 18 inches minimum. It must also be protected from damage, such as by running through polyvinyl chloride conduit. Underground feeder cable is not suitable for direct burial in masonry structures. It should be run inside approved electrical conduit or raceways. The underground feeder cable should not exit the piers without proper termination or protection in an approved electrical box. Weatherproof boxes require knockout seals and connectors for all openings to prevent moisture intrusion. Turning to plumbing violations, polyvinyl chloride pipes are not designed for electrical wiring. They do not provide the necessary insulation or protection from mechanical damage. The next steps involve informing the homeowner and explaining the violations and the potential consequences of failing to address them. Then, recommend a licensed contractor, advising the homeowner to hire a licensed electrical and plumbing contractor to rectify the violations and obtain the necessary permits. If desired, offer to assist with the permit application process. Finally, schedule a follow-up inspection once the violations have been corrected and permits have been obtained. When dealing with underground feeder cable, remember that the National Electrical Code, or NEC, specifies burial depths based on voltage and location. For residential branch circuits, like the 12/2 underground feeder cable in question, a minimum depth of 12 inches is generally required when the cable is protected by a ground fault circuit interrupter, or GFCI, and is used for a 120-volt circuit or less. However, without ground fault circuit interrupter protection, an 18-inch burial depth is typically mandated. When the underground feeder cable is installed under a driveway or other area subject to vehicular traffic, the required depth increases to 24 inches. It is essential to consult the specific requirements of NEC Section 300.5 and local amendments, as jurisdictions may have more stringent regulations. The protection methods can include encasing the cable in rigid metal conduit, intermediate metal conduit, or rigid polyvinyl chloride conduit. The type of protection depends on the location, potential for physical damage, and local code requirements. When running underground feeder cable through conduit, the conduit must be properly sized for the cable fill and be suitable for direct burial. Underground feeder cable should never be directly embedded in masonry. Masonry is porous and can trap moisture, leading to cable degradation and potential electrical hazards. The cable must be enclosed in a raceway approved for direct burial, such as rigid polyvinyl chloride conduit or rigid metal conduit. The raceway provides physical protection and prevents moisture from coming into direct contact with the cable. When transitioning from underground to above ground, a proper junction box must be used. This box serves as a termination point for the underground feeder cable and allows for a transition to wiring methods suitable for above ground use. The junction box must be weatherproof and listed for the environment in which it is installed. Connectors used to terminate the underground feeder cable in the junction box must be appropriate for the cable type and the enclosure. Weatherproof boxes play a critical role in protecting electrical components from moisture, corrosion, and physical damage. These boxes are designed with features that prevent water from entering, such as gasketed covers, threaded hubs, and corrosion-resistant materials. However, to maintain the weatherproof integrity, it is essential to use knockout seals and appropriate connectors. Knockout seals are used to close any unused openings in the box, preventing water or other contaminants from entering. These seals are typically made of rubber or plastic and are available in various sizes to fit different knockout diameters. Connectors are used to secure conduits or cables to the box and provide a watertight seal. These connectors must be listed for wet locations and be compatible with the type of conduit or cable being used. Proper installation of knockout seals and connectors is essential to ensure that the weatherproof box maintains its protection against moisture and environmental factors. Always follow the manufacturer's instructions and local code requirements when installing these components. Polyvinyl chloride conduit, or polyvinyl chloride, is commonly used in electrical applications for its durability, ease of installation, and resistance to corrosion. However, not all polyvinyl chloride pipes are suitable for electrical wiring. Plumbing-grade polyvinyl chloride, such as drain, waste, and vent, or DWV polyvinyl chloride, is not designed for electrical use. Electrical polyvinyl chloride conduit is specifically manufactured to meet the requirements of the NEC and is listed for electrical applications. It has different properties than plumbing polyvinyl chloride, including thicker walls, higher impact strength, and resistance to flame propagation. Electrical polyvinyl chloride conduit is also subject to stringent testing and certification requirements to ensure its safety and performance. Using plumbing-grade polyvinyl chloride for electrical wiring can create serious safety hazards. Plumbing polyvinyl chloride is not designed to contain electrical conductors and may not provide adequate insulation or protection against physical damage. It is also not resistant to heat, which can cause it to soften or melt under electrical loads. In addition, plumbing polyvinyl chloride is not listed for electrical use, which means it has not been tested or certified to meet electrical safety standards. When selecting polyvinyl chloride conduit for electrical wiring, always choose electrical-grade polyvinyl chloride that is listed and labeled for electrical applications. This will ensure that the conduit meets the necessary safety standards and provides adequate protection for the electrical conductors. When correcting electrical violations, it is essential to follow a systematic approach that addresses each issue in a safe and compliant manner. Firstly, conduct a thorough inspection to identify all violations and potential hazards. This inspection should include a visual examination of the electrical system, as well as testing of circuits and components to ensure they are functioning properly. Secondly, develop a plan to correct the violations, prioritizing safety and compliance with the NEC and local codes. This plan should include a detailed scope of work, a list of materials needed, and a timeline for completion. Thirdly, obtain all necessary permits before starting any work. Permits ensure that the work is inspected by a qualified electrical inspector and that it meets all applicable codes and regulations. Fourthly, hire a licensed electrical contractor to perform the work. A licensed contractor has the knowledge, skills, and experience to correct electrical violations safely and effectively. Fifthly, follow the electrical contractor's instructions carefully and ask questions if you are unsure about anything. Electrical work can be dangerous, so it is essential to take all necessary precautions. Sixthly, after the work is completed, schedule an inspection with the local electrical inspector. The inspector will verify that the work has been done properly and that it meets all applicable codes and regulations. Lastly, keep all documentation related to the electrical work, including permits, inspection reports, and contractor invoices. This documentation will be helpful if you ever need to sell your home or make an insurance claim. When assisting a homeowner with the permit application process, it is essential to provide clear and accurate information and to guide them through each step of the process. Firstly, explain the purpose of the permit and the benefits of obtaining one. Emphasize that permits ensure that the work is done safely and that it meets all applicable codes and regulations. Secondly, help the homeowner determine which permits are required for the specific project. This may involve contacting the local building department or consulting with a licensed electrical contractor. Thirdly, gather all necessary documentation, such as plans, specifications, and contractor information. This documentation is typically required as part of the permit application. Fourthly, complete the permit application form accurately and thoroughly. Make sure to provide all required information and to answer all questions truthfully. Fifthly, submit the permit application to the local building department and pay any required fees. The building department will review the application and may request additional information or revisions. Sixthly, track the status of the permit application and respond to any requests from the building department promptly. This will help to ensure that the permit is approved in a timely manner. Lastly, once the permit is approved, make sure to post it in a conspicuous location at the job site. This will inform inspectors and other interested parties that the work is being done under a valid permit. When scheduling a follow-up inspection after electrical violations have been corrected, it is essential to ensure that all work has been completed according to code and that the electrical system is safe and functioning properly. Firstly, review the original inspection report to identify all violations that were cited. Make sure that each violation has been addressed and that the corrective action taken meets the requirements of the NEC and local codes. Secondly, visually inspect the electrical system to ensure that all wiring, components, and equipment are installed correctly and are in good condition. Look for any signs of damage, deterioration, or improper installation. Thirdly, test the electrical system to verify that it is functioning properly. This may involve testing circuits for proper voltage, current, and grounding, as well as testing the operation of electrical devices and equipment. Fourthly, verify that all required safety devices, such as ground fault circuit interrupters and arc fault circuit interrupters, are installed and functioning properly. These devices are designed to protect against electrical shock and fire hazards. Fifthly, ensure that all electrical panels and junction boxes are properly labeled and that all circuits are clearly identified. This will help to prevent confusion and errors in the future. Sixthly, document all findings and any corrective actions taken. This documentation should be kept with the original inspection report and should be made available to the homeowner and any future owners of the property. Lastly, if any violations are still present or if the electrical system is not functioning properly, notify the homeowner and recommend that they contact a licensed electrical contractor to correct the issues. Electrical safety is paramount, and it is essential to ensure that all electrical work is done safely and according to code. When discussing permit fees with a homeowner, it is essential to provide a clear and accurate explanation of the costs involved and the factors that influence them. Firstly, explain that permit fees are typically based on the scope and complexity of the electrical work being performed. Larger and more complex projects will generally have higher permit fees than smaller and simpler projects. Secondly, inform the homeowner that permit fees may also be based on the value of the electrical work being performed. This means that projects with higher material and labor costs will typically have higher permit fees. Thirdly, explain that permit fees may vary depending on the location of the property. Some jurisdictions have higher permit fees than others. Fourthly, provide the homeowner with an estimate of the permit fees for their specific project. This estimate should be based on the scope of work, the value of the work, and the location of the property. Fifthly, explain that permit fees are typically paid to the local building department at the time the permit application is submitted. The building department will review the application and determine the final permit fee based on the information provided. Sixthly, inform the homeowner that permit fees are non-refundable, even if the permit is not approved or if the project is cancelled. Lastly, explain that permit fees are a necessary cost of doing electrical work and that they help to ensure that the work is done safely and according to code. Permits protect homeowners from unqualified or unscrupulous contractors.